Hello, and welcome to this video on Oracle Linux kernel module configuration. The Linux kernel is loaded into memory by the bootloader. New code can be added to the kernel by including the source files in the kernel source tree and when compiling the kernel. But Linux also supports loadable kernel modules, or LKM, that allow you to add code to a running kernel. Kernel modules are dynamically loaded and unloaded on demand. They provide device drivers to allow the kernel to access new hardware, support for different file system types, and generally extend the functionality of the kernel. To list currently loaded modules, use the lsmod command. For viewing more details about a specific kernel module, use the modinfo command along with the module name. There's a difference between recognizing kernel modules. Kernel module file names have a .ko for extension, which stands for kernel object. Kernel modules have an extension of .ko.xz instead of .ko and are compressed. Let's explore kernel modules more. Use the lsmod command and pipe the results to more to list kernel modules currently loaded into the kernel. The size column displays the amount of memory the module uses. The used by column gives a total number of processes that are using the module in addition to any modules that depend on the module, with the names of the modules that depend on the given module shown last. Hit the spacebar to view the rest of the results, and then clear the screen with the clear command. Next, use the modinfo command to list detailed information about a specific kernel module. Notice that the kernel modules are loaded from the /lib/module/kernel version/kernel directory. Use the uname-r option command to display the kernel version. Type clear to clear the screen. List the kernel modules for the kernel version, piping the output to the less command. The actual kernel modules have a .ko or kernel object extension. Kernel module names end with .ko.xz because they are compressed using the xz compression. Kernel modules are loaded by using the modprobe command. The device manager for the Linux kernel, udev, uses modprobe to load drivers for automatically detected hardware. To load kernel modules, use the modprobe command along with the name of the module. To unload kernel modules, use modprobe command again with the -r option followed by the module name. A kernel module may have dependencies. Dependent modules are loaded first. Some of these modules may, in turn, be dependent on other modules. Kernel module dependencies are listed in /lib/module/kernel version/modules.dep, which is created by depmod when kernel modules are installed. For loading specific kernel modules at boot time, the directory used is /etc/sysconfig/modules. Let's determine whether the NFS kernel module is currently loaded. Run the lsmod command and pipe the results to grep to search for the NFS module. As you can see, the NFS kernel module is not loaded. Use the modprobe command with the -v option for verbose to load the NFS kernel module. Notice that modules fscache, grace, and lockd are loaded in addition to the NFS module. These modules must be loaded in order for NFS to run. Also notice that modprobe uses the insmod command to load the modules. Confirm that the NFS module is loaded along with the fscache, grace, and lockd modules by running the lsmod command and piping to the egrep command to search for the pattern NFS or grace. Notice that the NFS, fscache, grace, and lockd modules are loaded. The output shows that the NFS module depends on the lockd, fscache, and sun RPC modules. The lockd module depends on the grace and sun RPC modules, while the grace module depends on the sun RPC module. Now let's list the kernel module dependencies for NFS. Again, use the grep command with the -w option, searching for the word pattern nfs.ko in modules.dep. The dependencies listed in the modules.dep file for NFS correspond with the modules loaded when running the modprobe NFS command, except for the sun RPC module. Finally, let's unload the NFS module. Clear the screen by entering the clear command. Run the modprobe command with the -r option, which uses the rm mod command to remove the modules. The "-v option was also used for verbose purposes. Lastly, verify that the NFS module was successfully removed. Run the lsmod command and pipe the results to grep for searching for NFS. As you can see, the NFS module was removed. Just as the kernel can accept boot time parameters to modify the behavior of the kernel, kernel modules can also accept parameters to modify their behavior. The syntax for passing parameters to a kernel module with modprobe is modprobe the command, then the module name, followed by the parameter equal value pair. Multiple parameter value pairs can be passed by separating the pairs with spaces. Ensure that the module is not previously loaded, because modprobe does not reload the module. The configuration directory for modprobe is etc/modprobe.d. Files in this directory end with a .conf and are used for the following purposes: to specify options used with kernel modules, to create aliases or alternative names for a module, to override the normal modprobe behavior for modules with special requirements. The format of these .conf files is one command line per line. Valid commands to use in these files include alias, options, install, and remove. This concludes the video. Thank you for watching.